Hi, this is Dr. Cora Stack here. Cora Stack. I wanted to talk in this video. I want to make one point, and I've been attending a conference, and really what I'm saying is artificial intelligence. I wouldn't use this word now, but say it's not magic. It's not a mysterious brain or an artificial brain. This is my thesis, that at its foundation, it's a designed mathematical system. And once we understand that, we can begin to ask much sharper questions about the important things: accountability, governance, fairness, and public trust. Much of modern artificial intelligence is built on mathematics, especially linear algebra. When an AI system processes information, it is often working with vectors, matrices, weights. Well, they're called weight matrices, but weights are put into, they're the entries, parameters in a weight matrix: transformations, functions, activations, probabilities, thresholds, constraint, and optimization. These are not vague ideas. They are mathematical structures. A piece of text, an image, a voice, or a human voice can be converted into numerical form. That numerical form is then represented as a vector. Vectors are transformed by matrices. Well, it's kind of affine transformations, but the matrix is hugely important here. Weights are applied. Layers process the data. Now, I'm saying a layer is really the key unit here. It consists of an affine transformation and a nonlinear function. So that's repeated over and over again, and then the output goes into the next layer and the next layer. So activation functions decide what is passed forward. Probabilities are generated. Thresholds may determine whether something is accepted, rejected, ranked, flagged, recommended, approved, or denied. This is the mathematical pipeline of artificial intelligence. And here is the key point. If AI is built through mathematics, then it must also be made accountable through mathematics. We cannot govern AI properly if we do not understand the structures that produce its outputs. We simply cannot look at the final answer and say, well, the machine decided, like if we do an appeal now, for example, this is not enough. We must ask what data went into the system, how was the data represented, what vectors were created, what matrices transformed them, what weights were applied, what features were prioritized, what assumptions were built into the model, what probability was produced, what threshold was used, what constraints were imposed, what was the system optimizing for, and who decided these design choices. These are not only technical questions, they are governance questions, they are accountability questions, they are democratic questions. Because AI systems are increasingly being used in areas that affect real human lives. They may influence access to employment, education, housing, credit, insurance, healthcare, legal services, policing, migration, welfare, and public administration. If a person is denied an opportunity because of an AI-assisted decision, then that person should not be left facing a black box. There must be a meaningful way to ask, why did this happen? What factors contributed to the outcome? Was the process fair? Was the data reliable? Were the assumptions valid? Was there bias? Was there a human review? Was there an appeal? And was the system mathematically and ethically accountable? This is why linear algebra matters so deeply. Linear algebra gives us a language for a structure. It allows us to see that AI decisions are not floating in the air. They arise from transformations, they arise from numerical representations. These are all designed. They arise from learned weights design. They arise from optimization process. They arise from designed choices. And designed choices can be questioned. And they are human decisions, not made by a machine, by a particular person in a large chain. Designed systems can be audited. Designed systems can be regulated. Designed systems, more importantly, can be improved, but only if we know where to look. This is also a difficult point that must be said clearly. Many people, including many in mathematics, science, education, law, politics, and public administration, are still in denial about the scale and speed of artificial intelligence and the current harm that it's currently doing to huge swathes of people
across the globe. Some see AI as a useful tool, some see it as a passing technological development, some assume it will mainly affect other people, so it's not about them, other professions, other sectors, they don't have to worry because it doesn't affect them. But this is a dangerous misunderstanding. AI is simply not another piece of software. It is a general purpose technology that may reshape work, education, decision making, knowledge, creativity, administration, and even democracy itself. It may also affect our own professions, it may affect our students, it may affect our children, it may affect how society decides who gets access. This is what I'm very concerned about. Who gets access to opportunity, employment, housing, credit, education, healthcare, justice and public services. I mean, it's shocking, in my opinion. Unless serious steps are taken now, AI may develop in the wrong direction. It may become more powerful while becoming less accountable. It may become more efficient while becoming less humane. It may become more widely used while becoming less understood. It may be presented as neutral while embedding the priorities of those who designed it, found it, trained it, or deployed it. This is why denial is no longer an option. We need mathematicians, educators, lawyers, policymakers, technologists, academics, students, and citizens to engage seriously with what is happening. And I am calling on the mathematicians to wake up is probably the wrong word, but to really get on board behind this. Of course, a strong moral compass would help. But sadly, we simply cannot assume that every company, institution, government or developer will act with one, very sadly. Good intentions are not a good governance system. Trust is not an audit. Ethics statements are not accountability. We need structures, we need laws, we need mathematical scrutiny, very important. We need transparent design. We need independent audits. We need appeal mechanisms. And I mean, appeals at the moment. How could you have any faith in an appeal from somebody who has absolutely no knowledge, no mathematical, not of anything I'm talking about? We need public interest governance, and we need this before the technology becomes so embedded that meaningful challenge is also possible. And that is the way it is at the moment. At the moment, it's almost impossible to challenge because you're dealing with someone who has no understanding or isn't even perhaps allowed to understand or has no training in the mathematics required to understand the technology. And there's so many layers, there's so much part of it, and it's so diverse, it's so divided up, that's almost impossible to say, who's responsible. So we also need to be honest about how AI is already being used. Students are using it, academics are using it, professionals are using it. Look, the consultancy firms, right, left and centre, accountants, lawyers, all of these high-powered professionals are all using it. And all these, I won't mention any particular consultancy firms, but they're all using it. The glossy brochures that they produce, they're all AI. Institutions are using it. It's everywhere. And many people are beginning to rely on it so heavily. We must also speak openly about dependency, overuse, and even a form of addiction to instant answers, instant writing, instant judgment, and instant production. I mean, I was talking to someone today, and they said they found a student in a lecture, in an exam, and they were, had it under the table in an exam, and they were, obviously had to be taken aside, etc., etc. And cheating, sure, I mean, is that the only person in the world that has the chat GBT to calculate under the table? I wonder. I very much doubt it. But anyway, this is it's the addiction. But this would be unrealistic on happen. But the people who are trying to manage the learning from ChatGPT and also having a fair exam would feel very hard done by if they felt somebody who was using ChatGPT in an exam to get ahead of them or cheat. This is very understandable. AI can support good work. It can help people draft, organise, explain, translate, summarise, analyse and learn. So there are good things, and a lot of students would say it's very helpful in that regard. It can open doors for people who are overwhelmed, excluded, disabled, isolated or under-resourced. Certainly it can. Used well, it can be a powerful education and professional tool. But that is precisely why we must take it seriously. We should support the good uses of AI because I can't see it going away. So we either accept that it's there, and then it's how do we, the good, the bad, and the ugly, as I call it, about AI. We should acknowledge its value, but we must also seriously condemn the harms. We must condemn the misuse of AI to deceive, exploit, manipulate, surveil, replace human judgment, weaken education, de-skills professional or high responsibility behind a machine. The answer is not denial. The answer is not blind enthusiasm either. The answer is accountability. AI must be properly understood. It must be mathematically understood. It must be ethically governed. It must be legally accountable. And I'm really getting back to the point. It must be mathematically understood. And it must remain subject to human responsibility. This is why I believe AI governments urgently need mathematical expertise. And it has to be deep mathematical expertise, not superficial. It has to be expert mathematical expertise. Legal regulation obviously is essential. Ethical principles are essential. Public policy is essential. But they are not enough on their own, clearly. If those responsible for governance do not understand the mathematical machinery beneath the system, then they may only be regulating the surface. They may be looking at the language, the branding, the interface, the final output, while missing the deeper structure that produced that decision. I mean, to me, it's absolutely clear that AI cannot be governed without the involvement of mathematicians at a very senior level at all layers of decision making and governance. This is a very serious accountability gap. AI may appear smooth, polished, as we know, intelligent on the outside. Somebody said recently in Ireland, AI was brilliant, but underneath there is a mathematical engine, and that engine, that's what's brilliant, the mathematical engine, and that engine must be understood. The public needs better explanations. Decision makers need better mathematical literacy. Regulators need access to mathematical expertise. Absolutely. And institutions using AI must be required to document, explain, and justify the design of the systems they rely on. All of this huge everything. So I will say that again. Institutions using AI must be required to document, explain, and justify the design of the systems they rely on. There should be a whole load of questions there that I put that should be answered. We need audit trails. We need transparency around data. We need clarity around features and weights. I mean, what current person involved in an appeal can ask these questions, genuinely speaking? We need scrutiny of thresholds. We need a review of optimization goals. We need to understand what the system is being asked to maximise and what it may be sacrificing in the process, because optimization is never neutral. A system optimized for efficiency, which we're always hearing about, the efficiency, may sacrifice fairness. Not only that, somebody today, it's optimizing, it's sacrificing real productivity, which is absolutely right. A system optimized for profit may sacrifice care. A system optimized for prediction may sacrifice historical injustice. A system optimized for speed may remove meaningful human judgment. This is why the mathematics of AI is also a question of values. The equations matter, the matrices matter, the vectors matter, the thresholds matter, the constraints matter. But how many people currently involved in writing a letter to somebody, the AI system said this, undersaid any of this? I mean, it's betrayal of humanity. It's a betrayal. It's a betrayal of people that this is happening, in my opinion. That's a strong word, but I actually think it's a betrayal. It's a betrayal of governance to allow this to happen, of government to allow this to happen, of the regulators, it's a betrayal of the regulators to allow this to happen. And a lot of people just do not have the mathematical expertise, but there's no reason why they shouldn't. They should be aware of the importance of the expertise required. It's an absolute betrayal of humanity, because behind each of these lie human decision about what counts, what is ignored, what is rewarded, and what is penalised. It might sound a bit strong, but I think you couldn't be strong enough when you're talking about the harm that's caused by the bad and the ugly of AI. If students, well, there's plenty of good, but there's bad and ugly. So we want to move away from all of that, and we need all of these things. So if students, academics, governments, companies, courts, hospitals, schools, and employers are going to, which they are already doing, there's no point in being in denial, they're already doing it. And society has a right to know how these systems work. We have a right to know what they're doing. We have a right to know how they're reliable. We have a right to know why they're dangerous, where they're dangerous, and we have a right to know who's responsible when harm occurs. So we cannot have powerful systems shaping human lives while nobody is clearly accountable. I mean, this is the central issue. Artificial intelligence must be understood as a designed mathematical system. And once we see this, we can demand accountability, we can ask better questions, we can build better governance, we can insist on auditability, we can protect human dignity, and we can ensure that AI serves the public interest rather than become another hidden system of power. Mathematics built AI. Mathematics must now help make AI accountable. AI can support good work, but only accountable AI can be trusted. Thank you for watching. And so that's my take. I'm at a conference and I'm trying to rally the troops, but it's very difficult because it seems to me that so many people are in denial about the harm that AI could be capable of, is already doing. They can't see it, and it is really it is a betrayal of so many people that this is not that governance, and even the EU, I would say, and I've always supported the EU, but I really feel even the EU Act is behind the curve in terms of what I'm saying here. It's significantly behind the curve, and perhaps because people involved in designing that act were not I won't say mathematically blind, but they were not mathematically literate about all those design features, which could have a very, very harmful effect on the future of humanity. So that's just my take for the moment on it, and I think there are great opportunities for AI, but there is a huge amount of of harm that could be caused unless some of the things I'm saying are taken seriously.